you want to show the undo. Again, these are more freebies that you get from using the traits package, that you don't have to reinvent these wheels by yourself. Alright, now I'm going to show you one more adaptation of this program. This is a little more complicated, and what I'm doing here is I'm taking two separate objects. Each of them would be an instance of my sum to 42 program, and I'm going to sync them. I'm going to run them side by side, and I'm going to show you how some of these advanced trait listeners work. So you can see in the source that I use this onTraitChange decorator, and what that's going to do is it's going to listen to variables within the program, and it's going to update them accordingly, and it's easier to see when it runs. So the whole concept is I'm using a few of the prepackaged tools in the Enthought tool suite, and I can build a generally sophisticated application, and you can see this is still pretty small. So let's run ex4. Alright, so now what you see is I have two objects, object 1 and object 2. Each of them is the program that I've been using, and they each work separately. So if what I should say is that there is a main A and a main B, and you can see that I synced the traits A and B throughout this program. You can see on the bottom that I have a notifier that's recording from where the changes are occurring. So if Rob changes main A, let's change main A, you see that the last event was master, and it's delegating down to the slaves. Now if Rob changes A or B in object 1, it understands that slave 1 is changing, and it's updating A and B, and so forth. So this is an example how you can use some advanced trait listeners to do some more sophisticated things, and building a program like this from scratch would be I think no less than 100, 200 lines. And again, this is a fairly small program, but it just demonstrates some of the basic tools and how traits work. The next thing I want to talk about are the so-called trait editors. Now, what is a trait editor? Basically, in the other program that I showed you, I never really defined any structure in my GUI, but you saw that a GUI was created. For example, those entry boxes were used to present my integer trait without me ever saying, hey, I want to use an entry box. This is because the traits by default have these default styles, and each trait has several default styles, but if I wanted, instead of an entry box, a more complicated interface that the user would use to change that trait, I would build one of these so-called trait editors. And there are a bunch of trait editors that come packaged with traits, and then you could build your own. And this is really how you don't sacrifice flexibility for simplicity. If you want to build simple GUIs, you get them for free. If you want to build more sophisticated elements to your GUI, then you can use these editors. So I'm going to show you some of the built-in editors that come with the traits package, and why they're so useful. This is a nice demo that comes with the Enthought tool suite, and it shows off some of their editors. So let's look at first. Let's look at the standard editors. Alright, so let's look at the button editor. This is just giving you a feel for what editors do. On the right panel, you see that there's a simple and a custom style for the button. So these are two different editors that present a different looking button to the user. And let's look at the color editor. Imagine you had a program which that you wanted the user to put in a color. If you use a simple style, you're going to get this drop-down color list. If you use, for example, a custom style, it's going to open the color wheel that's inherent to your operating system, and you get the users to pick a more custom color. So this is an example of an editor. Defining a different editor lets the user enter the same variable in a different fashion. The file editor is extremely handy. In a Python program, a lot of times you're going to want to input files. Now again, in the simple style, you can see that this is just a browse button that opens a window and lets the user put in a file. In the custom view, this window is already open. In the text view, then Rob would actually have to enter the path manually. But in any case, this is giving you an idea of how an editor works. It is redefining how the presentation of this trait itself is given to the user. And the table editor is also a good one to show. Table editors are nice for sorting, adding in lists or lists of objects. You can see that each one of these objects is actually a class in the program. And the tables come with these filters. They come with nice adding and removing element features, selections. So again, you get a lot of this for free, and it's really nice to use all these things. Now we're going to look at some of the advanced editors. These are editors that maybe you would build if you had to do more customized analysis. So let's look at the NumPy array tabular editor demo. The array editor, the tabular editor is kind of similar to an Excel spreadsheet, except it's much faster and it has a lot more power. So you see, I think there's 50,000 cells loaded in here, and there's no lag with scrolling, and this is not crashing. Oh, it looks like it's 100,000. So you know that in Excel, if you try to open 100,000 rows, you're most likely going to crash the program. And the guys at Enthought have built this such that it uses some C-level validators, and I don't know much about that. I just know that this is a really nice program, and it's probably useful to a lot of scientific applications. Let's also look at the adapted tree editor demo. Now I'm not going to talk about the advanced features, but I wanted to show the tree editor before. This is also nice when you have a natural structure that you want to give to your programs. And I can go on and on about this, but I think I'm just going to let you look at it. Let's look at the table editor with live search and cell. So this is a very advanced editor. You can see what Rob's able to do is he's able to choose a file type, and it understands it's built in which file extension he's looking for. Then it's going to let Rob choose a directory, and it's going to search his computer either recursively or non-recursively for such files. So you see when it's recursive, it's going to find some Python files. And then within those Python files, Rob is looking for any string that matches a certain string. Now when he chooses one, you'll see that it's going to open that file, and it's going to highlight where that word history was found. And you can see that this is a very sophisticated editor, the goal of which is to really select a file. Now, this is showing off some power Python because under the hood it's using a lot of OS and string matching and other things. But if you look at the source code, this isn't a gigantic program. I think maybe it's about 150 lines. A lot of them are comments and aesthetics, and this is easy to adapt. I've adapted this to a lot of uses in my programming. So it kind of shows you just how, if you really need customized editors, you can make them as complicated as your heart desires. So now I want to talk about a couple more tools that are also included in the Enthought tool suite, and they're built on top of traits and traitsui. So I think I've given you an idea of how these trait objects work, and using them you can build, Enthought has built some nice further application development tools. So CHAH-ko is a 2D plotting program, and the nice thing about CHAH-ko is that there's a very strong maintenance between your data space and your visualization. So CHAH-ko is highly suited for making interactive plot. CHAH-ko maintains a strong interrelation between your data space and your visualization and the mapping therein. This is nice if you want to build plots that need to update with user input. Now this might be a bit convoluted for creating static plots, but once you're past static plots, the learning curve is very steep to get this interaction. And again, CHAH-ko is built on top of traits, so if you understand traits, you're going to understand how to build in CHAH-ko. And I think CHAH-ko is best demonstrated by example. So we're going to load the CHAH-ko demo up, and again, a lot of these demos are nice learning tools. They come packaged with Enthought tool suite. So let's look at some of the basic plots first. Let's look at the line plot. Now the basic log plot, this is just showing a demonstration of a static plot. So this is kind of a plot that you could build in any plotting program, and it's not much different in CHAH-ko. So you can use CHAH-ko to build these simple static plots. Now you can really start to see some of the power in this, one with large data sets. So again, this is a static plot, but it's plotting 1,000,000 points, and there's more going on under the hood than your basic plot that you would generate in another program. So if plotting large data sets is a problem for you, This also might be a good alternative because there's a lot of C-level validators working here. Now let's look at some interactive plots. Let's look at the linked line and scatter plots. Now you see here I have two plots, and I believe if Rob drags one of them, then the axes are linked. So the axes are being represented by traits, and the event notifiers are working in all the same way, but you see now that they're working in a plot context and not just in basic Python variables. This works for zooming, scrolling, etc. He can drag either plot, I think, and you get the same. Oh, I guess the tool is only on the left plot, excuse me.
I just wouldn't include that part.
Okay. Now, let's see, what are some other good ones? Let's look at the traits-based function plotter. What we have in the bottom is an equation which is corresponding to a trait object, and that's going to be fed into a numerical Python array. So when Rob changes this to cosine x, the plot updates immediately, cosine and sine. And you can also change the plot type, for example, from a line to a scatter plot using this enumeration trait. And this is very simple to achieve. So again, if you look at the source code, I think the source code to this is pretty small. I mean, except for the view, which is that big chunk in the middle, it's probably about 15 lines, except for inputs and views. So you've got an interactive plot that updates on any function that you put in, and it's a robust application, and you get all that for more or less free, just demonstrating the utility of this program. Let's look at some of the tools, the CHAH-ko tools. Here's an example of some of the tools you get with the CHAH-ko plot. So the range selection tool allows Rob to scroll along, and it'll capture all the data in this x-axis. Now, like I said, there's a good maintenance between the data space and the visualization. So if the data within this was useful to you, then you're going to be able to extract it just by selection. That's the kind of interactivity that's hard to find in other programs. The regression tool is a really nice, is going to demonstrate this nicely. So Rob's using the lasso selection to select a series of data points, and based on what's inside his selection, the program is going to run a regression and plot a line of regression just for the points within there. And now you can kind of see what I mean with the transparency between the visual representation and the underlying data. And you can see the linear fit to this regression at the bottom. And there's also a toolbar, and there's other tools, I'm sure. The toolbars, if you scroll up to the top of the plot, it should come up. So you can save, zoom, you can do some of these nice features that you'd expect with a good plotting program. Let's look at the image plot as well. CHAH-ko is pretty good or very good for 2D plots, image plots. Now, I don't do a lot of this in my research, so I can't really go on and on about it, but you can see some basic plots. Here's a nice one. You see as Rob scrolls along the contour, the underlying data points are shown on the top right. This could be useful to a lot of different fields, I imagine. Now, these are some basics. If you really want to look at the advanced stuff, this is really going to show you how CHAH-ko can really fly. So if this 2D function inspector is a nice program, it lets you enter any two-dimensional function, and it's going to plot the contour of it. This is a more advanced example. You can see that there's a two-dimensional function being plotted, and Rob is able to interactively scroll across the contour map, and as he does, the X and Y cuts in that contour map are shown on the inset plots on the right and underneath. And you can get a sense of the contour by the shape of these curves. You can see that the curves update in real time, and the colors are maintained with the points in the curves. What we're not showing you, but is more functional in this program, is that you can enter any two-dimensional function that you want, and you can also change these color libraries as well. We're not going to show that off, but some advanced features. The audio spectrograph is a particularly cool example. It uses Pi audio to interface whatever your microphone is recording and update the plot in real time.